Hey, welcome to Build an AI. I'm Nia, your AI learning guide. Let's get into it.
Welcome back to the Explainer. Today, we're getting into something that literally shapes every interaction we have on the modern web: JavaScript Asynchrony and the Fetch API. You know those seamless, fluid web experiences you love? Well, we're going to break down exactly how this tech transforms our apps from frozen, unresponsive screens into those dynamic, real-time experiences. Let's get right into it. Okay, let's dive into this. Here's our roadmap for today. We're covering the cost of waiting, single-thread execution alongside promises and async await, the Fetch API itself, and finally, debugging and UI states. Section 1. The cost of waiting. So think about the last time you opened a chat app, or maybe a weather app, and you just stared at a completely blank screen. You're furiously tapping your phone, and you've got absolutely no idea what's happening. Is it loading? Did your Wi-Fi drop? Should you just toss your phone out the window? It's an incredibly frustrating experience, right? When an interface just sits there in silence, users immediately assume the whole thing is broken.
And that right there brings us to the core challenge we face as developers. Almost no app today runs on purely static data. The front end is constantly relying on external services, databases, and APIs. And let's be real, those take time to respond, or sometimes they just fail completely. Managing that wait gracefully, keeping the interface active and fluid even when the backend is dragging its feet, that's the absolute hallmark of a reliable modern application.
To actually manage that, we break the user experience down into 4 essential visual UI states. Think of these as your communication tools to keep the user in the loop. We've got idle, where nothing's happened yet; loading, when an operation has officially kicked off; success, when that data arrives perfectly; and error, for when things go completely off the rails. Every single asynchronous operation needs to map to these exact visual signals. And this brilliantly illustrates the state machine for an app's lifecycle. We start at idle. The second a user triggers an action, say clicking a search button, boom, it transitions immediately to loading. From there, it branches out. We hit success if we get our data, or error if it fails. The real beauty here is that from either success or error, the system can return right back to idle, or jump straight back into loading if the user tries again. The user is literally never left in the dark.
Section 2. Single thread, promises, and async await.
First up, we've got to understand a fundamental limitation. JavaScript is single-threaded. It only has one call stack, which means it executes code sequentially, instruction by instruction. Picture a super busy worker who can only do one single task at a time. If that worker stops everything to wait 500 milliseconds for a server response, the entire browser page just freezes. No scrolling, no clicking, nothing. So how does JavaScript actually survive this? Well, it delegates. So, what's our escape hatch? Take a look at this architecture flow. On the left, we have our single call stack. When it hits a slow task, like a network fetch, it immediately delegates it to the web APIs in the middle. The browser basically handles the waiting in the background. Then, once the data arrives, the result gets pushed over to the task queue on the right. Finally, the event loop checks if the call stack is empty, and if it is, it pushes the result right back in. This whole cycle is the absolute secret sauce to non-blocking JavaScript. Now, back in the day, developers managed all these delayed tasks using callbacks. But as you might know, that often led to callback hell, that deeply nested pyramid of code that just looks like a modern art disaster. Today, thankfully, we use promises. Promises totally upgraded callbacks by giving us trackable states and linear chaining. It makes our code infinitely more readable and so much easier to debug. A promise is exactly what it sounds like. It's an object representing the eventual result of an operation that just isn't ready yet. It acts as a placeholder, and it always exists in one of 3 highly trackable states: pending, while it's still doing its thing; fulfilled, when it succeeds with a value; or rejected, when it fails and throws an error. If we simulate a 1-second delay here, check out how we use the .then and .catch methods. These are basically automated catchers. The .then steps up to handle the successful result, and the .catch perfectly centralizes our error handling. And the best part? While that promise is hanging out waiting for that 1-second timer, the rest of your program just keeps right on running, completely smoothly. But we can actually make this even cleaner using modern syntax. We can make our asynchronous code read exactly like normal sequential code, and it just takes 3 simple steps. Step 1, wrap your code in an async function. Step 2, slap the await keyword right in front of the promise. And step 3, handle your errors like a pro using a standard try/catch block. Let's move to this and see how it builds.
This recommended async/await pattern flows incredibly logically. From top to bottom, you declare your async function, you await your promises right in the middle, and you wrap the whole shebang in a try-catch block for totally robust error handling. It literally eliminates those messy promise pyramids for good.
Section 3. The Fetch API. Fetch is JavaScript's native tool for making HTTP requests, and to use it right, you need to rely heavily on what we call the double await pattern. Step 1. You await the initial network request to grab the headers and status. But here's the trick, that actually doesn't give you the data yet. Step 2 requires a completely separate second await on response.json. Decompressing and reading that raw body is a totally distinct asynchronous step. We kick off the fetch, and we get a raw response object back. But getting to that final data requires us to call response.json, which again is itself an async operation. Only after that crucial second await do we finally reach the usable JavaScript data object. If you skip that second await, your app is just going to break. No way around it. And that brings us to what is easily the biggest silent trap in modern JavaScript, the Fetch API gotcha. If a server responds with a 404 not found or a 500 server error, Fetch does not reject the promise. Let that sink in. Your catch block will completely ignore it, and your app will just pretend everything was a massive success. You have to explicitly and manually validate response.ok before you ever try to parse that data. Section 4. Debugging and UI states. When your asynchronous operations inevitably fail silently, because we've all been there, you need to run through these 5 rapid-fire diagnostic checkpoints. First, did you remember to mark the function async? Second, did you forget the await keyword? Third, is your error actually being caught in a try/catch? Fourth, did you manually validate response.ok? And finally, did you remember that absolute game changer, the second await on the JSON parser? This right here brilliantly maps common console symptoms straight to quick, actionable solutions. If you see promise pending logged to your screen, the cause is super simple. You forgot an await. If your catch block is completely bypassed on a 404, you forgot to validate response.ok. This table is basically your cheat sheet for solving the most frustrating silent errors in web development. Bringing the whole narrative full circle, let's look at a search flow. A single centralized render function explicitly cycles the UI through our core states. We go from idle down into loading, and then branch out to either a success or an error message. Doing it this way guarantees that no state ever gets stuck in limbo, and your user is always informed. So the crucial point is that asynchronous code really isn't magic. As we see here in this complete stacked pipeline, it all starts with a foundation of promises for an uncertain future, layered with async await for that beautiful readable flow, utilizing fetch for the actual data requests, and finally capped off with those critical UI states. It's not magic, it's just beautifully organized architectural plumbing. Which leaves us with this final provocative thought to ponder. As developers, you now have the exact tools needed to banish those frustrating blank screens forever. So how will you handle uncertainty in your next build to keep your users fully informed? I highly challenge you to apply these patterns and build deeply reliable communicative apps. Thanks for tuning into this explainer, and happy coding!
And that's a wrap for today. If this lesson was helpful, go ahead and hit that subscribe button so you never miss a new episode. We drop 3 new lessons every single week, all designed to help you learn, build, and launch with AI. Share this with someone who's on the same journey, and I will see you in the next one.